Physical reality at its heart is the four fundamental forces: gravity, electromagnetism, and the weak and strong nuclear forces. The so-called conflict between general relativity and quantum mechanics has two reasons. The first is because relativistic effects don't correlate to observed atomic phenomenon. Relativity is fundamentally about the gravitational force. Gravity is astronomically weak compared to the other fundamental forces. It is the domain of large objects like planets, stars, and galaxies. The weak nuclear force is 10 to the 25th power times stronger than gravity. Electromagnetism is much stronger than the weak nuclear force, and the strong nuclear force is even stronger. Gravity is far too astronomically weak to have any effect on atomic phenomenon. The term quantum gravity has virtually no basis in physical reality. Atomic phenomenon is the domain of electromagnetism, the weak nuclear force, and the strong nuclear force. The second reason is about singularities. Singularities are a mathematical construct only and do not exist in physical reality. Einstein is known to have repeatedly spoken about this. In the 1939 journal Annals of Mathematics, he wrote, "The essential result of this investigation is a clear understanding as to why the Schwarzschild singularities—" Schwarzschild was the first to raise the issue of general relativity predicting singularities— "do not exist in physical reality. Although the theory given here treats only clusters, star clusters, whose particles move along circular paths, it does seem to be subject to reasonable doubt that more general cases will have analogous results. The Schwarzschild singularities do not appear for the reason that matter cannot be concentrated arbitrarily, and this is due to the fact that otherwise the constituting particles would reach the velocity of light." Singularities have always been a stubbornly persistent fictional term. Attempts to unify general relativity with quantum mechanics is attempts to unify the ununifiable,